Okay, good evening, everyone. My name is Chao Chen-Ru, and I'm the moderator of today's event. We are going to have a Chemi Chat regarding Chemistry Chapter 2, Atomic Structure. Later, our speakers, Jianing, Sasha, Najiha, and Yue will share some questions and solutions related to this topic. Before we start, I would like to remind that we'll have a lucky draw session. The winners will be selected through the wheels of names, sorry. So don't forget to fill in the attendance link. So now we can start with the question number 1. Let us welcome our first speaker, Jianing.
Okay, good evening everyone. So I'm the speaker for question 1. I'm Cha Jianing. The question. Can move to the another slide or hello? Okay, so this is our first question, which is, according to Bohr atomic postulates, the excited electrons will fall back to a lower energy level by emitting a specific amount of energy and producing a series of lines. By using the energy level diagram, draw the transition of electrons, the first 3 lines that resulting in the formation of Lyman series and Balmer series. Okay, so from the question, we know that we need to draw a energy level diagram. So this is what we will get as what question had mentioned, that we actually just need to draw the first 3 lines. So for the Lyman series, it occurs when electron falls to n equal to 1. So our first line will be n equal to 2 fall to n equal to 1. And the second line will be n equal to 3 falls to n equal to 1. And the third line is n equal to 4 to n equal to 1. While for the Balmer series occur when electrons fall to n equal to 2. So our first line is going to be n equal to 3 into n equal to 2, and the second line is n equal to 4 into n equal to 2, and the third line is n equal to 5 to n equal to 2. Yeah, is my explanation is clear? Is there any question? If not, then we can move to the next question.
So thank you, Jianing. Then we will move to our second question. Let us invite Sasha to talk about this question.
Hello. Good evening, everyone. My name is Nadia. So I'm going to present question number 2. So the question says that calculate the wavelength and frequency of the second line in Lyman series. And we know that dia cakap Lyman series kan, maksudnya n final dia akan sama dengan 1. And dia cakap kat sini second line. Second line which means first line dia mesti akan jadi n equal to 1. Dia punya transition tu from n equal to 1 to n equal to 2 to n equal to 1. Dia nak second line. Second line maksudnya n equal to 3 to n equal to 1. So dia nak, kat sini soalan dia nak wavelength and frequency. We'll be using this formula which is 1 over lambda equal to RH which is a Rydberg constant in bracket 1 over n1 squared minus 1 over n2 squared. So kat sini n1 mesti lagi kecil daripada n2. That's how we decide which one is n1 and which one is n2. So we substitute all the numbers into the formula, and then kita akan dapat dia punya wavelength is equal to 1.026 times 10 negative 7 meter. The next dia nak frequency. So frequency kita boleh guna kita boleh guna formula speed of light over lambda. Dia dapat dah lambda dia tadi 1.026 times 10 negative 7 meter, and speed of light is a constant, which is 3 times 10 power of 8 ms negative 1, and substitute into the formula and we got the frequency is 2.92 times 10 to power of 15 as negative 1. So that's all from me. Is there any question?
Okay, thank you, Najiha. Sorry, the speaker just now is Najiha but not Shasha. Okay, let us invite our third speaker, Yiwei, to talk about the third question.
Hello everyone. Us to calculate the ionization energy for the hydrogen atoms in kilojoule per mole. And to solve this question, we can separate into two steps. And first step is we can find the ionization energy for one electron. Therefore, we can find the ionization energy for one electron by using the formula. Energy difference equals to Rydberg constant, bracket 1 over initial energy level square minus 1 over final energy level square. As we know that the Rydberg constant has a values of 2.18 times 10 power to negative 18. Okay. And then the ionization energies involve the transition of electron N1, which is the lowest energy level that is nearest to the nucleus, to infinity, which is the highest energy, and the energy level that is furthest away from the nucleus. Therefore, we can let the initial energy levels as 1 and then the final energy levels as infinity. And next is come to the calculations. In the third line, we can see that 2.18 times 10 power to negative 18. Then we 1 divided by 1 will be equal to 1, and 1 divided by negative infinity, 1 divided by infinity will be 0. Therefore, we can get the answers for one electron is 2.18 times 10 power to negative 18 joule. Next slide, please. Thank you. Okay, next to step 2 is we have to find the energy for 1 mole of electron. Why we have to find the ion energy for 1 mole of electron? Because according to the definitions of ionization, and ionization energy is the minimum energy needed to remove 1 mole of electron from 1 mole of gaseous atom at the ground state. Therefore, we have to find the ionization for 1 mole of electron. Therefore, how we calculate the ionization energy for 1 mole of electron? We can use the answers from previous slide, which is 2.18 times 10, multiply the constant, which is that we learned in 6.02 times 10 power to negative 10 6.02 times 10 power to 23. After pressing the calculator, we can get the answer 1.12 times 10 power to 6. The calculation cannot stop here because the questions ask us to find in kilojoule per mole. Therefore, we have to divide it by 10 power to 3, which is the prefix for kilo. Therefore, we can get the answers. We get the answers 1.312 times 10 power to kilo per mole is 1,312 kilojoule per mole. That's all for me. Thank you.
Okay, thank you, Yue. And
Do you guys
have any questions? Um, so now, so now we have already gone through half of our event. So let's take 5 minute breaks. And for this 5 minute break, you can you can you can go and relax and drink some water. Thank you.
Pahit hidup dan pengorbanan terpaksa dihadapi demi kejayaan. Terdidik sejak mula, tambah berusaha, tanpa cuba melangkah tak kemana. Di mana kau berada, pencapaian tak tiba dengan mudah. Kini standing in the eyes of the world,
Okay, welcome back. The 5-minute break is over, and please fill in the link shared in the comment section to participate in the lucky draw. And now let's now let us invite Janine to be our speaker.
Okay, hi again. Okay, so this is our question 4. And the question is, give all possible values of n, l, m, and s for an electron in the orbitals of A is for 2p. So in order to solve this question, I think we need to have some basic concept for this, which is n is actually the principal quantum number which indicate the energy level and size of an orbital, while m is magnetic quantum number which indicates orientation of the orbital. So for L is actually our angular momentum quantum number which indicates the shape, and also S is our electron spin quantum number which indicates the spinning motion of electrons, and our value of S will only be positive 1/2 which represent clockwise, or negative 1/2 which represent anti-clockwise. So our first question is that 2p, so our n will be 2 because 2p is located at second shell, and our n is equal to 1 because 2p has p orbital. Since our L is equal to 1, so our n will be negative 1 or 0 or positive 1, and our S can be in only positive 1/2 or negative 1/2. So let's move on to B. B is 3D. So 3D is located at third shell. So n will be 3, and 3D has d orbital, so L will equal to 2. Since our L is 2, then our value of m will be negative 2 or negative 1 or 0 or positive 1 or positive 2. And as well as our S will always only can be in positive 1/2 or negative 1/2. So I think that's all for me. Okay, thank you.
Thank you, Janine. And now let's move on to the next questions. And don't forget to fill in the kehadiran link. Okay, let's invite Shasha to tell us about the fifth questions.
So number 5, chromium is an element in the block of the periodic table. Write the electronic configuration of chromium. Explain the anomalous electronic configuration in chromium. So the electronic configuration of chromium, according to Aufbau principle, is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d4. Anomalous electronic configuration in chromium is 1s2, 2s2, 2p6, 3s2, 3p4, 4s1, 3d5. Explain the anomalous electronic configuration in chromium. Chromium can achieve extra stability by forming half-filled 3d orbital. One electron of 4s orbital occupies one of the empty 3d orbital in order to have a half-filled 3d arrangement. So electronic configuration of chromium, anomalous electronic configuration tu is more stable than the normal electronic configuration. So next question. So number 6, copper is the 9th element in the first row of D block of the periodic table. 6.1, Write the electronic configuration of copper according to the Aufbau principle and the actual configuration as determined by experiment. The electronic configuration of copper according to Aufbau is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d9. And the actual configuration determined by experiment is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d10. So give reasons for any anomaly. Fully filled 3D orbital or half filled 3D orbital is more stable compared to partially filled orbital. So that's why one electron of for s orbital to occupies one of the empty 3D orbital to achieve to have a fully filled 3D arrangement in copper. Okay, so that's all.
Okay, thank you, Shasha. So now it's time for our lucky draw. We are going to choose 5 lucky winners. So before we start the lucky draw, please give us some time to prepare. Okay, thank you. Let me share screen. Okay. So this will be our lucky. Can see screen ah. Boleh buka. Okay. So let's spin. So the first winner is Tong Li Xuan. Congrats. Yeah. Okay, let us move on to the next winner. Woo! Adam Daniel bin Azmi. Congrats. No Farah Jahwa binti Zainal Abidin. Sorry. Congratulations. So now is the fourth. So this is the fourth, third. So now is the fourth. Muhammad Anas Arumi bin Muhammad Hidayat. Congratulations. Fakhru Razi bin Muhammad Khoiri. Congrats. So these people are the lucky winners. So thank you very much. Our live session has finished now. Thank you for participating in this event, and thank you and good night. Happy Deepavali.